Far to the south, he read, at the frontier outpost of Syene, something notable could be seen on the longest day of the year. On June 21st, the shadows of a temple column or a vertical stick would grow shorter as noon approached. And as the hours crept towards midday, the sun's rays would slither down the sides of a deep well, which on other days would remain in shadow. And then, precisely at noon, columns would cast no shadows, and the sun would shine directly down into the water of the well. At that moment, the sun was exactly overhead. It was an observation that someone else might easily have ignored. Sticks, shadows, reflections in wells, the position of the sun, simple, everyday matters of what possible importance might they be. But Eratosthenes was a scientist, and his contemplation of these homely matters changed the world, in a way, made the world, because Eratosthenes had the presence of mind to experiment, to actually ask whether, back here, near Alexandria, a stick cast a shadow near noon on June the 21st. And it turns out, sticks do. An overly skeptical person might have said that the report from Syene was in error, but it's an absolutely straightforward observation. Why would anyone lie on such a trivial matter? Eratosthenes asked himself how it could be a stick in Syene would cast no shadow, and a stick in Alexandria, 800 kilometers to the north, would cast a very definite shadow. Here's a map of ancient Egypt. I've inserted two sticks, or obelisks, one up here in Alexandria, and one down here in Syene. Now, if at a certain moment, each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant, there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths. For the observed difference in these shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about.